Talk in this topic about measurement or how to quantify things a little bit. This is an incredibly important skill in the field of psychology. What we find is that so many things that we're interested in psychology are what we call hypothetical constructs. That is, they don't have a tangible existence. Okay, so in IO psychology, one of the biggest hypothetical constructs we'll come across repeatedly is job performance. What is job performance? I don't know. And so, because we have these hypothetical constructs, we need to use what are called operational definitions to define them. Okay? And so, operational definitions will numerically, they will assign numbers to what is job performance. Job performance is number of widgets per hour. Okay, straightforward now, okay? So I've quantified job performance in some way, shape, or form. So the hypothetical construct is job performance. The operational definition is number of products created per hour, okay? So when we measure, we do two things. Number one, if you measure job performance, you're going to measure job performance, okay? Number two, there's going to be measurement error. Because, of course, if you measure the number of products produced per hour, every single hour it's going to be different, right? If you measured at hour 1, 2, 3, 4, why? Because they got tired, or maybe they got on a roll so they did better, or God only knows, okay? So all measurement that is made has truth plus error, okay? So when it comes to numbers, and this is something that is incredibly relevant for your statistics class, it's less relevant here. Not all numbers are equal. That numbers can contain up to 4 different properties. Okay, and so it turns out numbers can have either one property or 2 or 3 or 4. Right, and it turns out that the first property is the ability to name things. Okay, so nominal scale data, which is sort of the lowest type of data, has simply one characteristic: it can name things. That is, chocolate is different from vanilla when it comes to ice cream, okay? Got it. Chocolate and vanilla are different from each other. Great. Ordinal scale data allows you to put things in order, okay? But it also allows you to distinguish and name them. So if one student got an A and one student got a B, the A is different from the B. Great. That's naming. And the A is higher than the B. That's putting it in order. Sweet. The third scale of measurement is interval scale, and it contains 3 properties. That is, naming, the numbers are different from each other. Ordering, you can put them in order. And then you have equal intervals between them. Okay? So, say, stepping back a second, if one student had an A and one had a B, you have no idea what the difference is between them. It could be 1 percentage point, it could be 12 percentage points. You don't know. You just know that one is higher than the other. But with interval scale data, the difference between them is the same. Okay? But the one thing that's missing with interval scale data is this idea of a true zero. Okay? And so a true zero means that if the number comes up 0, it literally represents the item does not exist. And so true zero, how many apples do you have? If you have 0 apples, there are no apples in front of you, okay? So we find that ratio scale data is the way the world works. In reality, that is to say, the world of the caveman is the world of ratio scale data, because with interval scale data, because 0 does not represent an absence of the product, you can have negative numbers, all right? And so, can you imagine a caveman talking about -4 apples? It's like, no, okay? So real world data tends to be ratio scale. Much of the modern world data is interval scale. Okay? So when we're making a measurements, as I said, we're measuring truth plus error. And because of this, we need to be concerned with 2 major things when it comes to it. That is reliability. That if I measure something, if I measure it a second time, will I get the same result? If I measure a person 50 times across 50 different days, will their job performance be the same 50 times in a row. That's reliability. Validity has to do with, is the measure that you're making actually reflect what you think it reflects? So I'm measuring number of products produced per hour as my measure of, as my operational definition of job performance. But as I briefly mentioned earlier, there are so many other elements of job performance, because the idea is you're going to come to this, oh, if somebody produces many products per hour, then they're a good employee and they deserve to be promoted. Yes, but what if they're poor quality? What if their behaviors are such that they're bringing down everybody around them? Now, all of a sudden, the idea of using number of products produced per hour as a quantifiable measure of job performance means it's invalid. It's a bad measure because it's not job performance. It doesn't reflect it. Okay? So we need to know that reliability and validity are established using correlations, and all measures that we make, and measures say dependent variables here, but all measures that we make have some reliability and validity. It's just some have more, some have less. Okay? So validity can come in many different forms, right? We can see in this little diagram, off to the right, we'll talk about first, and we've already talked about them. That is internal versus external validity. And if you're looking at an entire research study of sorts, you would talk about internal and external validity. But if you're measuring an individual construct, an individual variable, then we go down this path with construct validity. Okay? And in the world of construct validity, there's lots of ways to establish construct validity. In particular, if you travel the path from criterion validity down, lots of different ways to establish these validities. Okay? So the internal versus external argument, we already had this conversation when we talked about descriptive research methods. Or rephrase that, nothing about it. When we talked about laboratory experiments, we said they tend to be high in internal validity because we can control. Field experiments tend to be high in external validity. We lack control, but the behavior that we're measuring is probably reflective of what people actually do in reality. Okay? Now, we find that if we have done a good, clean experiment and we have high internal validity, then if I repeat my study, I'm probably going to replicate it. Okay? If I have done a field study and have established high external validity, chances are the findings from my study will be generalizable to other settings, other forms. Okay? So it's a trade-off, right? Trade-off. Going down the other side, if I'm measuring a single variable and I want to know whether or not my measurement reflects the underlying hypothetical construct, we talk about construct validity. So clearly there's lots of ways, lots of constructs, hypothetical constructs in psychology. As I said, job performance is one of them, but look at, here's a handful more: self-esteem, intelligence, cognitive ability, self-control. Psychology is littered with hypothetical constructs, and we cannot work with hypothetical constructs unless we operationally define them, and our operational definitions may or may not be valid. Okay? Reliability, as we already said, is this the ability to repeatedly measure the same thing over and over and over. And just like validity, there's a variety of ways that we can measure reliability, including things such as test-retest, which is straightforward. It has to test the same people twice. You could do split half reliability. Give somebody a test and take half of the items and get a score on it, and half the items and get a score on it, and compare them. Or lots of other ways we might do so. Okay? So that is, measurement in a very, very, very short nutshell for you.